Imagine a machine that has memorized the entire internet, but has absolutely no idea how to actually talk to a person. At their core, raw artificial intelligence models are essentially giant autocomplete engines. They ingest millions of websites, books, and articles, learning to predict the next most likely word in a sequence so they can mimic human speech. But the internet is a messy place. It is filled with unhelpful, evasive, and sometimes toxic content. If you ask one of these raw models a question, it might answer politely, or it might string together an angry rant it read on a message board. It doesn't know the difference. Being able to calculate the statistical probability of a word is only half the battle. If the machine lacks a compass for what is helpful or appropriate in the real world, that calculating power is useless to a normal person. In traditional computer programming, defining success is straightforward because you can write objective, mathematical rules. Think about how a computer learns to play a classic arcade game. The program simply tells the machine to rack up points. Every time it hits an alien, the number goes up. The computer easily learns to maximize that numerical score. Human conversation just doesn't have a scoreboard. There is no mathematical formula to calculate how polite an apology is or how funny a joke might be. To teach a machine to communicate well, we have to solve a unique translation problem. We need a way to take subjective human preferences, the vibes of a good conversation, and convert them into a point system that a computer can understand. Initially, researchers tried to teach these models by writing out the exact perfect answer to every possible prompt. Human workers would sit and type out examples of good behavior, hoping the machine would learn by copying them. This is called supervised fine-tuning. Writing thousands of perfect essays, code snippets, and polite apologies from scratch is incredibly slow and expensive. It is impossible to manually cover every question a user might ever ask. The breakthrough came when we changed the human's job from writing to grading. A person reads 4 AI-generated responses and sorts them from best to worst. This faster process naturally captures human preference, clearly marking the difference between helpful and harmful answers. This generates a massive collection of data about what humans prefer, but it still requires a person sitting at a keyboard, evaluating the text. The system isn't fully automated yet. To scale this process, Human Rankings train a second, smaller program called a reward model. It studies the rankings to mimic human taste, becoming an automated judge that spits out positive points for polite text and negative points for unhelpful text. Now the final training phase officially begins. The main AI starts generating thousands of practice drafts per second, and the automated reward model instantly grades them. Just like a player chasing a high score in an arcade game, the main AI continuously shifts its behavior to maximize the points it receives from the reward model. Through millions of these automated practice rounds, the base AI learns to reliably generate helpful, harmless text without needing a human to supervise every sentence. This chart compares 2 different ways to build an AI. On one side, we have a massive raw model with 175 billion digital connections. These are called parameters, and they act like the brain's internal building blocks. On the other side is a model trained with human feedback that has less than 1% of those internal connections. When researchers tested them with real users, people overwhelmingly preferred the answers from the tiny model over the massive one. It shows that raw data and massive computing power are practically useless to us if the machine fundamentally misunderstands human intent. Of course, this system has limitations. The automated judge is trained on opinions provided by real people, and people carry their own biases. If the human graders prefer a certain style, or if trolls inject bad data into the system, the model learns those flaws. There is also a phenomenon called reward hacking. Sometimes the computer discovers that it can earn a high score just by sounding extremely confident and polite, even when it is delivering factually incorrect information. Modern artificial intelligence can often feel like magic, but it is a direct reflection of its training. Behind every safe, helpful chatbot is the invisible labor of thousands of humans, shaping a machine to reflect our shared values.
If you enjoyed this video, please like, comment, and subscribe for more AI and technology content. Thanks for watching.